All right, what's up, guys? It's Professor B, and today I'm back with another physics problem. It's we're gonna be doing some vectors today. So without further ado, let's get started. It says the problem says two-dimensional vectors A and B have the same magnitude. So right off the bat, they're telling us that vector A, the magnitude of vector A is equal to the magnitude of vector B. The angle of orientation for these vectors, respectively, are so for theta A. The angle is 37 degrees, and for theta B, the angle is 75.0 degrees. Now, they're giving us a vector C. It says the vector C is related to vectors A and B by such relationship. So the relationship is C is equal to A minus 2B. So this is the relationship they're giving us, and that is how that is how the vector C is related to vectors A and B. And this says the magnitude and direction for the vector C is 6.12 and the angle is 281.9 degrees. And they want us to determine the magnitude of vectors A and B. So because the magnitude of vectors A and B are the same, we only need to solve for one magnitude, and that will give us the magnitude of the other as well. So let's draw out the problem and see where our vectors lie. So we have the x and the y axis. So we're going to draw our vector C, and we're going to make it in pink. So it says it has an angle of 281 degrees. So from the unit circle, we know that this is 0, this is 90, this is 180, and this is 270 degrees. So 281 is just a little further more. So we're going to assume that all angles are measured in the positive direction, counterclockwise from the x-axis. So that's going to be our angle, our vector C with a magnitude of 6.12, and our angle is 281.9 degrees. Now we're going to do the vector B. So we don't know the magnitude, but we do know the angle of this vector, which is 75. So we know right here is 90 degrees, so a little less. The 90 minus 15 should be should be about right here. And that angle is 75.0 degrees. Now we're going to use yellow to draw our A vector. Again, we don't know the magnitude, but we know the direction is 37 degrees, and we know that this line right here is 45. So a little less than that would be about right there, and we can call this angle 37.0 degrees for vector A. And this one is vector B. So now that we have our vectors drawn out, what we're going to do is we're going to use all of the x components of each of our vectors, and those x components are relatable by our relationship that we have right here. So let's start off with the pink vector. So we know that c sub x, the x component for the c vector, because remember that for a vector they have a x component and a y component, and the resultant vector is the sum of those vectors. So the x component is going to be the magnitude times cosine of 281.9 degrees. Now, we're going to do the same thing for our a vector. So a sub x, we don't know the magnitude, so we're going to let the magnitude just be a. And we do know the angle, which is cosine of 37.0 degrees. Now, we're going to do the same thing for b. So b of x, for the x component, again, we don't know the magnitude of b, but we know the angle, and we know the angle is 75.0 degrees. So because we have this relationship where our vector c equals a minus 2b, then we can use that to find our magnitude of a or b. So we're going to write, using this relationship right here, we're going to write c sub x is equal to a sub x minus 2b sub x. Now, we know that c sub x is 6.12 cosine of 281.9 degrees is equal to a cosine of, because a sub x is equal to a cosine of 37.0 degrees minus 2, and b sub x is b cosine of 75.0 degrees. Now, because the magnitude of a and b are the same, we're going to let a and b be the same. So we're just going to call both of those m. So we have 6.12 cosine of 281.9 degrees is equal to m. Factoring out m, we have cosine of 37.0 degrees minus 2 cosine, minus 2 cosine of 75.0 degrees. So dividing both sides by cosine of 37 minus 2 cosine of 75 degrees, we have 6.12 cosine of 281.9 degrees all over cosine of 37.0 minus 2 cosine of 75.0 degrees. And you should get, after you put that into your calculator, you should get 4.49, and that is the magnitude for A and B. Thank you so much.